So hi people, sorry for the delay. We're extremely sorry for the delay. Just need 5 more minutes. Ask your friends if anyone is there to join as soon as possible. We'll start by 6:25.
Okay, so Freshers, how's your project going for that you're making for BotAstra? You can write in chat box.
Like, did you people find the project like interesting, the problem statement, or like is there anyone who didn't actually understand at all the problem statement that she or he was given? Is there anyone still who hasn't understood the problem statement? मार्केटिंग वाला
So,
पार्ट पेंडिंग है. Yeah.
so we have to use only those concepts that you have told us, like those sensors, like that you have taught us about.
No, you can use sensors that we have. Of course, we couldn't teach about all the sensors in a 2 hour window, right? So you can use sensors that you find would be useful for you in this project. But also take like keep in your mind about the budget of the thing. It should be as inexpensive as it can be.
Okay, sir.
Yeah.
And if, sir, we are using some op-amps and transistors, so there's no need to write pseudocode, right?
I mean, if you're using transistors, basically, there's no point of writing code for that. But I don't think there's any such problem statement that you can completely develop using only op amps and transistors. So yeah, uh, all the sessions are live on YouTube, so you can go through that. The PPTs will be shared later on, like later on, as in we'll talk about that. We'll share it in 2 or 3 days. So not worry about that. Yeah. So okay. So how have been all the 3 sessions till now? Like you had all 3 sessions, right? Electronic, mechanical, yeah, 3 sessions. So how are people finding those sessions? Like, is it very complex for you people, or are we going very fast? Last was very good. Okay, okay. Also, like if you have any doubt, feel free to ask questions in the group. All right, like you people have would be in a group, right? Every one of you. So
Yes.
there are two or three seniors or four maybe. I don't remember. Feel free to ask a question in there. They're there for you only, like all the way till you make a project. Yeah. Mhm. Yeah. So I think we can start in 2 minutes, right? Shobit.
Yes, there are about 100 participants, so you can start.
All right. Sure.
So,
Yeah.
so we have to show the code that we have used for the project in our PPT presentation.
See, you can provide a pseudocode, right? Pseudocode is basically what you want to do with the code. You need not go into the syntax part of the code. We don't want you to write an Arduino code right now. All you have to give us is like conditionals and like, uh,
Algorithm.
yeah, what you are basically gonna do. That's it.
Okay, sir.
That's all we want. Yeah.
Excuse me, sir.
Yeah.
Sir,
Also, just a minute, Rohit. Just a minute. Whoever is gonna speak further on, please raise your hand. When we ask you to uh, like unmute yourself, please do after that. Yeah. Yeah, Sumit, you can go on, ask your question.
so for the first board, for first meet with the seniors in the
Yeah.
BotAstra, so
Hmm.
do we really have to make the PPT, or first we have to show idea by really speaking it? Because for the
Uh,
first time, it may be not possible to create all the PPTs. Means I have gathered all the info, but
okay.
I just can't means do the presentation type things.
I don't think the presentation is too long. Dhruv, are you there in the media? Dhruv is there. Like, can you provide like
Yes,
what
sir.
supposed to provide us in the first meet? I mean, the first round.
Yeah, I think you can tell us what your idea has been about the problem statement
Yes,
that
that
you have
that
understood.
can I do. That can I do. Means whatever the problems we are actually means we have given.
Okay.
I have searched for all the things which are needed to solve them. And
Right. So yeah, so that is what we require. You have to identify the components that you will be required to use that we want.
okay, sir.
And in what round are they supposed to provide us with PPTs? Dhruv?
Um, I think this the first meet that he was talking about is just about telling us their idea and the components that they've identified. The final PPT that they have to present is on 16th that they have to submit, and presentation has to be done on 18th of Feb.
All right. Yeah.
Okay,
That clears
thank
your
you, sir.
doubt, right, Sumit?
Yeah, definitely. Thank you, sir. Thank you, Dhruv, sir.
No
Uh,
problem.
Udayan. Yeah, Udayan Chatterjee.
Yes, sir. Recently saw that in the chat someone wrote about marketing. So since it's a pitching event, so do we need to
Yeah,
do the marketing part?
I was also concerned about that thing. I don't know what who wrote about the marketing thing. I
It's not
maybe
required, right?
Actually, I think Udayan, what he meant was we need to make it a budget friendly, right? That's what he was talking about.
So actually, like let me just add on it. Like we had a pitching competition earlier, so there it was about marketing. So I think he's
yeah.
confused about that. So I was
This is a
asking,
tech
we don't.
club. Udayan just say this is a tech club. We need not bother about the marketing or sales
Okay,
thing.
okay.
We
Thank
can
you,
do
sir.
that. Yeah.
Thank you, sir. Thank you, sir.
Sumit
Okay, I
Gupta.
got it. Okay. Anyone else, if they have this marketing problem? Actually, the presentation we shared, we had a mistake from our side. There were some extra slides on marketing. Please ignore those slides. Only see till slide 9. Okay, sir, can we start the session?
Yeah, sure. Please go.
Okay. Good evening, everyone. I, on behalf of Team RoboISM, welcome you all to the fourth workshop. And today we are going to discuss topics in the fields of artificial intelligence, that is AI, machine learning, ML, and deep learning, DL. So let's get started. Let's answer the top three questions present in your mind right now. What is AI? What is ML? What is DL? Let's see what's written here. Artificial intelligence, programs with the ability to learn and reason like humans. Well, that's what people like to think. It's not really so. It's not even near to that. In reality, AI can do some tasks, but not as good as humans. Yes, sorry. As some people were talking about in inductions, we are nowhere close to making something like Jarvis. And what is machine learning? Machine learning includes algorithms with the ability to learn without being explicitly programmed to do so. They use certain parameters related to the input data to learn these algorithms. And deep learning is a more complex form of machine learning, and they use artificial neural networks, which you will learn about further in this session, to learn and adapt using vast amounts of data and solve a problem. Let's go further. Here I've given you some proper definitions of AI, ML, and DL. You can refer to this when the slides are shared. Okay, now there's one thing that you might be confused with, even I was when I was learning these things. What is the difference between ML and DL? This illustration will help you with that. In ML, there is input from humans. We decide what features are to be considered while training using the data, while training the model. But in DL, the model also learns these parameters by itself during the training and then improves on these parameters to increase the efficiency. There are many applications of artificial intelligence that we see every day, like in virtual personal assistants like Siri and Google Assistant. They use machine learning, they use artificial intelligence. There is natural language processing, also the Internet of Things that you have learned about in a previous workshop. They all include AI. Let's dive deeper into machine learning now. Let's start by having a look at what steps are involved in machine learning. I will explain this to you in a very interesting way. Since in machine learning, the machine learns in a very similar way to us humans. Let's see. First of all, we find ourselves a task. Suppose we have a task. In machine learning also, we have some task, some problem to solve. And suppose in an analogy, I'll say that the task for us is to learn maths. Then the first step would be to gather data. We gather data from some sources. Suppose we need to study maths, the first thing we'll do is we will look for different books and sources to study. Now the step 2, after we have gathered data, is to clean data according to our needs and remove the unnecessary data. Just like how we may find hundreds of or 200s of books on maths, but we only choose 5 to 6 from to study from, which are best suited to our needs. And the third step would be to build a model. And what is a model in machine learning? It basically is the algorithm which will take the data and process it to get the output. And in a similar way, going back to our analogy, we develop a studying plan to study maths to get good marks. And the fourth step is to gain insights from the model results. After the model has done some processing, it has got some output. We see how well the model has performed. And in the analogy, it can be referred to as how good marks we are getting using that studying plan, whether the studying plan was good or not. And the step 5 is to compare different models in machine learning. Suppose some model did good results, some did bad results. So we compare different models, their statistics, and then choose the best model for us. Similarly, how we devise different studying plans and then choose the one that best suits us. So these are the steps involved in ML. I hope you understood this. Let's go further. There are three major types of machine learning. Supervised learning, where training data and labels are present. Unsupervised learning, where the whole learning is data driven. And then there is reinforcement learning. Now this is a bit advanced topic, so I won't go deeper into reinforcement learning in this lecture. Here you can see a very nice pretty diagram showing us the types and their uses in real world problems. Like supervised learning, it can be used for classification problems, like it can classify and tell whether an image is of a bus or a car. Then we have unsupervised learning, which can be used in recommender systems. What are recommender system? We all do online shopping. Now, if you do online shopping, then would have seen that you always get recommended products that are best suited to you. Like suppose you are going to buy a phone, then you will be once you search for a phone, then you will be always recommended different phones to buy. These are the applications of unsupervised learning. Then there's reinforcement learning, which is used in robot navigation, games, etc. We'll not go deeper into this. Let's see supervised learning now. Supervised learning is a machine learning approach that uses labeled datasets. That is, there is a training set containing inputs and also what their output should be. Data including parameters and the expected output is given to train a model that can perform the required task. Supervised learning can be separated into two types of problem when data mining is considered, which are classification and regression. You will learn more about this in this lecture only by my friends. There are different algorithms present for both classification and regression. Here I have given an illustration of a classification problem where the input data contains different objects labeled with different colors, and the algorithm learns how to identify which data belongs to which colors and classifies them accordingly. Now let's see unsupervised learning. Unsupervised learning uses machine learning algorithms to analyze and cluster unlabeled data. These algorithms discover the hidden patterns in data without the need of human intervention. Like you know what spam mails are. An ML model can learn what content is usually present in a spam mail, and then with the help of that, it can then recognize further spam mails and mark them accordingly. Here I've also given an illustration on an unsupervised learning model, how the model identifies the different shapes present and then clusters them accordingly. Now, many of us are confused between supervised and unsupervised learning. So here I've given some differences. In supervised learning, the algorithm learns from the training dataset by iteratively making predictions on the data and adjusting for the correct answer. It learns how to make it better so that it can always get the correct answer. Like it uses historical data to predict some output. We can use historical data for car prices to predict what should be the car price of a certain car, new car. And in unsupervised learning models, in contrast, they work on their own to discover the inherent structure, the hidden structure in unlabeled data. They still require some human intervention to validate whether the model is performing correctly or not, and to validate the output variables. For example, an unsupervised learning model can identify that online shoppers often purchase certain type of objects together. Like again, going back to that online shopping, phone shopping, that if we buy a phone, then we are more likely to buy a back cover or a tempered glass along with the phone. So this is done using a unsupervised model. It is often tough to decide which type of algorithm to use, whether to use a supervised learning model or an unsupervised learning model. So there are some points that can help us decide to which model to choose. Choosing the right approach for your situation depends on how your data scientists assess the structure and volume of your data. Data scientists are people who work in this field, machine learning. So yes, so to make your decision, there are three steps that help always. Like we should evaluate our input data. If the input data has labeled outputs, then it is best suited with the supervised learning, because in supervised learning we need input data and what should be their output. Then we should define our goals. If our goals are classification or regression, then we can use supervised learning. But if our problem requires clustering or our problems are based on recommender system, then we use unsupervised learning models. Now we can also look at different algorithms. If we know many different supervised learning algorithms or unsupervised learning algorithms, then we can figure out which algorithm best suits our to solve our problem and then choose our method accordingly. Okay, let's see what reinforcement learning is. In short, reinforcement learning is a machine learning training method based on rewarding desired behaviors and punishing undesired ones. Let me also explain what this image here is trying to say. There is an agent present here in an unknown environment. Suppose this is a bot in an unknown environment and it does some action in the environment. Now this action can be good for us or bad for us depending on what our job is. So according to that, there is some reward or some punishment. Now this reward and or punishment is stored in the memory along with the state in which the agent or bot is. Now the next time the bot is in the same state, it will work accordingly whether the last time this action was punished or it was rewarded, and thus it improves on its own. and the correct action is taken the next time. Okay, with this, now I come to the end of my presentation. We are open to questions for 5 minutes. Raise your hands before unmuting yourself, or you can write in the chat box if you have any questions.
Yeah, we can go on.
Okay, so Dhruv can continue.
All right. So I suppose all of you must have been overwhelmed with this introduction that Shobit has
Just a
given.
second, Dhruv, just a second. I think Abhay Gupta had a doubt. He raised his hand.
Yes, sir.
Yeah.
Okay,
Sir, what
Abhay,
are
you can ask your doubt.
labeled datasets and unlabeled datasets?
Okay, Suresh sir, I can take this.
Yeah, sure, sure.
Label datasets basically means that if you have some input, then you know what its output should be. It's labeled that this is the input, then it's labeled that its output should be this. This is a labeled dataset. And in unlabeled dataset, we don't know what the output should be or what is the correct output for that.
Okay,
Do
sir.
you
Thank
get
you.
it?
Yes, sir.
Okay. Any other
All
question?
right.
Okay, fine.
Okay. Thank you, Shobit. Hello, everyone. I am Drusha, and as you can see, I'll be guiding you through the linear regression part. Now, you have been, as I told, overwhelmed with all the introduction that Shobit has given. So try to digest it slowly. And now the part is a little bit more mathematical, but it is very interesting. So let's see. What is linear regression? Let's see. Linear regression is a machine learning algorithm which is based on supervised learning. Its objective is to perform a regression task. Now, what is this word regression? Let's try to understand regression. According to the dictionary, it is the process of prediction of values based on some independent variables. Now, what are independent variables? As we draw XY graph and I write a function y is equal to f of x, the value I can put of x, that x is the independent variable. Y is the dependent variable because the value of y will depend on what value of x I put. So now you can understand regression is the process of prediction of values based on some independent variables. For simplicity, let's refer to them as input variables, as I just told. So linear regression helps us predict some unknown value, let's say y, based on a given input value of x. The graph in the right part of the slide, as you can see, shows a basic linear regression model. The model predicts the dependent variables based on some independent variables. Now let's look into a simple regression problem. Below presented is a data frame. The column radio that you can see represents the money spent by the respective company in its radio advertising. It is the independent variable here because company is choosing how much to put into it. The sales column is the sales revenue that the company generates. So that is the dependent variable here. So that was one example of regression, a data set, data frame. Next slide, you can see our function, which is also called as model, looks something like this, where sales is equal to weight into radio plus bias. Now, as I just told, radio you can think as X because it is the independent variable. Sales you can refer to it as the dependent variable Y. So sales is equal to weight into radio plus bias. Isn't it similar to y is equal to mx plus c? It is a straight line. So scales are the predicted values and radio is the input variable. Now what is bias, you might say? Bias is just like y is equal to mx plus c. The c is the bias. It is a constant that is added to the prediction to add to make, if the values of sales are negative, suppose, that will make it positive. We will add a large positive constant bias value so that it makes sense to us, the data. Now why is this done? So that the prediction does not become heavily dependent on the radio variable. The task of our algorithm here is to predict a sales value given the radio value, right? I want y given x. What is weight? Weight is the coefficient of radio variable, as you can see, and it is changed continuously while we train the model. We will see what training the model means, and that will provide us a better accuracy of predictions. Once I have understood, once my computer has learnt the data that has been given to it. Now, in machine learning, our aim is always to increase the accuracy of our model. And this accuracy is calculated over what is called a cost function. Let's see what cost function is. Cost function takes both predicted outputs by the model and actual outputs, and then it calculates how much was wrong in the model. Now this is used to penalize the model when it makes wrong predictions. Now you can understand, I want to see how much my model predictions are different from actual output predictions. So one way that is to be done is to take their absolute value difference. That is one way. However, what is done is we take that difference and then we square it, and then we take its mean, then we take its root. This is very similar to what you have learned in alternating current in physics, root mean square. That is what it's called here as mean squared error, the cost function that will be calculated. So here we will use MSE abbreviation for mean squared error loss. Mean squared error loss is simply the average squared difference between observations and observations, which are the actual values, and the predicted values, as I just said. Now you can see the formula for MSE below, which is y is the original value of sales and y tilde is the value predicted by the model, the straight line that has been trained by the data that has been given to it. So n here is the number of predictions that we have to make at a time. In machine learning, we call this a batch. Let's look in the next slide. To minimize our cost function, this is a algorithm which is just named as gradient descent. Now let's see why it is named so. Gradient descent looks at the error that our current weight and bias give on data and update them in such a way that the error is minimized. Now, as seen in the figure, the steps that are taken in the direction where the minima of cost function lie is increasing our accuracy. As you can see, it is going, it is going towards the minima. So that will, of course, because I am finding the minima, that will make my cost function have its lowest value, which means lowest error. And that means each of my predicted values by that straight line is getting closer and closer to the actual value. So next thing, let's see what is known as training the model. As you saw earlier, I said this sentence, training the model. What is training the model? Training a model is the process of changing this weight. What is weight? I just said the slope of this line of y is equal to mx plus c. So that is changing the weights and bias in such a way that accuracy of our model increases. This simple straight line should be such that it is as close as possible to all these data points x comma y, so that the error that we calculated, mean squared error, is minimum. So how this can be done? Let's see. Training is complete when we reach an acceptable error threshold. What is acceptable error threshold? Threshold means some minimum value that I can handle, or that is approx, like it is acceptable. That error is acceptable. That is the threshold value. Or when subsequent training iterations fail to reduce the cost of the cost function. Now, before training, we need to give our weights and we need to put some bias so that then that y is equal to mx plus c ka m and c can change, and that can be updated. So first, weights and bias are given some random values so that our model can generate some random predictions and it will be trained further. Let's see the steps of training. As I said earlier, training will involve changing the weights and biases of the model so that it fits the data more accurately. Now, as seen from the top left to bottom right, we can see what this is known as the decision boundary. It is shifting and it is fitting the data points more tightly. Hence, it is increasing the accuracy of the model, right? Hope that made sense. Now, having trained out a model, we have achieved a pair of weights and biases that fits our data best. And in this case, it turned out to be 0.46 weight, that is the slope value, and the bias is 0.025 respectively. So what is the function that we can say now? The dependent variable, that is the sales revenue, is equal to 0.46 into the independent variable, which is x, or in this case my cost that I'm putting in, the radio expenses, plus 0.025. This can be used to predict new values that can be given as an input radio variable. Now, if I put some money, so that will tell me I should expect this much sales revenue back if I'm investing so much in radio money. So you can also see that during training this mean squared error value, it keeps on decreasing. So we can say that during training, the accuracy of our model has increased, and at the end we have reached a successful and fully trained model which can predict sales values given one radio value as the input. This is all for linear regression. The mathematics might be difficult at first, but as I always say, digest it slowly, try to understand what is happening. And next part, my friend Arjun will be explaining. And meanwhile, if you had any doubts in linear regression, you could please ask me.
Sir, please repeat visualization case, sir. Figure is not visible.
Which one?
That time. After training part, visualization. Yes, sir, that part. Figure is not visible, sir.
The images,
Images is not
some
shown.
issue with the image.
We'll share the PPT with you later on. So it it is not that difficult to understand the figures. You'll get that later on. So yeah.
Okay, sir.
Yes, Parsh has a question in the chat. He says, why we initialize weights randomly? Finally, it is the program that will do gradient descent. It will minimize the cost function, and it will find out 0.46 and 0.025 as the slope and bias value. However, if I don't give any initial value to my slope and bias in the program, then on what variables will my program, finally find out 0.46 should be given to slope and 0.025 is the value of bias that will fit the line properly. So I have to initialize the variables. I have to give them some random value initially. Hope that answered your question. All of this that is being taught in the sessions will be asked you as questions in your tests that you will be giving. Okay. Any other questions? I think Anmol has a question. Anmol Chabra.
Yes, sir. So
Yeah.
I am asking like why we have taken on 0.46 and 0.25, like if we go to 0.30.
Very good. We are not actually taking. It is what will be trained. As you saw, this mean squared error, how we calculated, we took the difference of actual values and what my model is predicting the values to be, right? But then we
So
took
if
the
we get
difference.
close to that, like if we get close to like 0.35 and 0. Like it would be 41, then it would be more accurate. Then who decides this data?
Sorry, can you again repeat your question? Couldn't follow you.
So in the training iteration, like we have taken 0.46 and 0.25. If
That's
we
the end result. Like that's the weight and bias that best fits our data. Like, are you talking about the random initialization or are you talking about the final result?
yes, final result.
Yeah, so those points, those basically two values, like the weight 0.46. So we can go to the next slide. Images are not visible in this slide, so can you go to the next slide? Yeah. So the weight 0.46 and the bias 0.24 are the best values that by which we can best fit our data. So that's the answer to our model. It's not like we have set the value 0.46 and 0.25. It's basically we had to perform a gradient descent and had to find out the best value for our problem.
Yes. Thank you.
That answers the question.
Yes.
Yeah. Thakur Satvik, you have a question?
Yes, so my question was related to this that sir first told that we took up the bias value so that the sales could be pushed up positive. Why are we trying to push it up to positive? Can't we see the real values that if our sales are going downhill, then we can stop the production and change the way? Why are we trying to push it up?
Dhruv, you take the question?
Sure, yes, sir.
Yeah.
The thing is, not in this case. Actually, I was not talking about the sales. There are other data frames where the values will turn out to be negative. which will be predicted by the model itself I was talking about, not in this particular example. There might be other data frames where you will get negative output values, which will be predicted by your model, and which will not actually physically make sense. For example, the number of articles, let's say number of apples, if you want to predict it with respect to some weather condition, if that turns out to be negative by the straight line that my model is finding, that would not make sense, right, physically. So in
Yes,
that
I
those
got it.
cases, so in that those cases I have to add some bias, so that
Okay,
you know that my model predictions come above zero and they
okay, sir.
become positive. Yeah,
Okay, sir. Yes, thank you.
yeah. All right, I suppose now Arjun can continue. Arjun?
Arjun, you are not audible. It's not audible, Arjun.
Uh, I think there's some problem with his audio. Mm. No, Arjun, I think it's still not clear. Your voice is not as expected.
Dhruv, can you take over? Like, I don't think Arjun can make it.
Sure.
Yeah, thank you.
All right. So let's continue with logistic regression. We'll see what this means. So logistic regression, now as you saw, you have seen one regression type, right? You have seen linear regression. What that predicts is just a straight line. Now, suppose I have some data frames which are of the form of a parabola, if suppose, let's say. So that will not be very feasible to then predict those values as straight line. In that case, we have more advanced curves that can be considered. And that one kind of curve, or I should say family of curves, can be given by calculating the cost function in the way of logistic regression. Now let's see. So what does all this mean? Let's start with example, right? That will make more sense. If I receive an email, then my model should classify it as spam or not, right? Or if I give it details about tumor, let's say, then my model should classify it as malignant or benign. That is not fatal, deadly, or it should not be deadly. Also, if I give images of a dog, it should tell me if it is a dog or not. This is the main aim of each thing that you have to do in machine learning, so that automatically your machine finds out if it is dog or not, or whatever your problem is. So logistic regression predicts the output of categorically dependent variable, or we can say that it is used to classify objects into two classes. Therefore, the outcome must be a discrete value, right? It can be either yes or no, 0 or 1, true or false is what I mean. But instead of giving the exact value as 0 or 1, it will give us probabilities, right? Probabilities take, of course, values between 0 and 1. So that's a good analogy. It will give us probabilistic values, which will lie between 0 and 1. Let's dive deep into it. Let's see. So let's start with the math. Here, x1, x2, x3 are the inputs that we will provide to the model, and w1, w2, w3 are all, wn are all the weights that will be corresponding to the given inputs. Now suppose I have only two variables, x and y, and I have a series of data under x and y, and I can create one function. Let's say z is equal to ax plus by plus c, right? Or a1 x1 plus a2 x2 plus c, kind of that. So in 3D space, such a curve, or such that most of the data points lie closer to it. For example, let's say I am building a model to find out whether I will pass or fail in a test. So I have collected data for the number of hours I have studied. let's say that number of hours is x1, that number is x1, and let's say question paper difficulty is x2. I can plot this data as a function of x and y, right? You know, z is equal to f of xy will give me a surface or a curve in 3D space. I can plot this data in a 2D plane with question paper difficulty on y-axis and number of hours I studied on x-axis. My aim as a machine learning engineer is to predict if I would pass or fail in the test, given a new set of data for study hours and test difficulty. Now, disclaimer, please don't try this at home. But for this, I can create a function z is equal to ax plus by plus c, and we have to find values of a1 and a2 such that most data points lie on the curves. So till now, you might have got the basic intuition that my purpose is to make my surface or my line, whatever, as close as possible to each of the data frames that are lying in my 3D or 2D space. So similarly, you know, just generalizing things as mathematicians we like, with n variables, let's say, the output of the system we can create function y can be given as the linear combination of all these inputs, right? w1 x1 plus w2 x2 plus w3 x3, so on till wn xn plus bias again, some constant value. So in order to map these predicted values to probabilities, we use what's called a sigmoid function. Again, too much math. To make the value of y between 0 and 1, as probability lies between 0 and 1, cannot exceed 1, cannot be negative. We use this function called sigmoid function, sigmoid. Now what is this sigmoid function by definition? It is defined as sigma of z is equal to 1 by 1 plus e raised to z. Let's think about this. What's the minimum value that z can take? Minus infinity. So let's put it in this function, 1 by 1 plus e raised to minus infinity, which will be 1. Let's take infinity, z tending to infinity. That will give me 1 by 1 plus e raised to infinity, 1 by infinity, 0. So how magically you see this function 1 by 1 plus e raised to z has brought all my values. Whatever value I get z from minus infinity to infinity, any real value, it will squeeze it down to 0 and 1. So as you can see now, range of function has been restricted into 0 and 1. The aim of machine learning model is to optimize the output curve subject to the given constraints to fit most of the data points. Now to do this, we have to again train the model to get appropriate values of weights and bias to fit most of the data points that we have understood. Now to do so, we have to create a function which is called as a loss function. Now it describes how well the current output curve fits the available data, as you already know. If this function y that has been created, it does not fit the data well, then that means our loss function is very high, our error function is very high. Now if the curve fits the data well, then that means our loss is less. So for logistic regression, we use the following loss function. It is called the binary cross entropy loss function, gross entropy loss function, and cost function is nothing but loss function for m sets of data. Or we can say that cost function is the average of loss function for m datasets. To optimize the cost function, that is to reduce the value of the cost function, we use various methods, one of which is done using and you saw that this loss function is minus ya ln y minus 1 minus ya into ln of 1 minus y, and you will see how you can put a 0 and 1 and how that loss function will give values to you. Now to
Dhruv, can we pause? Like, Arjun, can you take over right now?
Yeah, I'm audible right now.
Yeah.
Okay. Hi guys, I'll start from the cost function. So, like he has defined what is a loss function. So, loss function here basically like for logistic regression, we use this particular loss function. So, this is called as a binary cross entropy loss function, and cost function is nothing but the loss function averaged over m sets of data. Now, as a machine learning engineer, what I need to do is to optimize my cost function or reduce the value of cost function, and there are various methods to do so. Next slide, please. Yeah. So one of these methods, like one of the most famous method, is called as gradient descent. So to find the local minimum of a function using gradient descent, we must take steps proportional to the negative of the gradient of the function at the current point.
So let me explain it by using the picture given, the image given right here. So let's take the case, let's take a point n on this graph. So at point n, if I find the derivative dy by dx at point n, and I will negate the direction of the derivative and move in that direction, then I will finally reach the minimum. So at each point, you will take this derivative, negate that, move in that direction, and you will finally reach the minimum. So next slide, please. Yeah. In this slide, we can see an animation of that. Okay. Now, if I plot the cost function along one of the axes and all the weights and biases on the remaining axis of an n-dimensional space. So you know that the input that we gave to the model, there were n inputs that we gave to the model, and there were n biases, n weights that we had, and a bias was also there for the model. Now, if I am plotting this, plotting the cost on one of the axes and the weights and biases on the other axis, then what I need to do is to reduce the cost function to get the maximum, to get the maximum accuracy. So loss function is basically loss function basically tells us the loss that we have. So if I plot a curve, if let's say I'm taking two inputs x1 and x2, and if I'm creating a model z equal to a w1 x1 plus w2 x2, I'm plotting that in space. And if I have a lot of data under x1 and x2, I'm plotting each of these data points in that same space. Then what I need to do is to have this curve in such a way that most of the data points will be available on the curve. But uh, initially, we don't know what will be the exact values of W1 and W2 to do that. So what we do is that we train a model. And if most of the data points are not on the curve, then the value of the loss function will be higher. And if most of the data points are within the curve itself, then the value of the loss function will be less. So what I need to do is to have most of the points within the curve, or to increase the accuracy, or reduce the value of cost function or the loss function. To reduce the value of cost function or loss function means if I plot the curve of cost function or loss function, let's say cost function, if I plot the graph of cost function, then what I need to do is to find the minimum of the cost function. Like I've explained in a two-dimensional space, to find the minima, what you need to do is to find the gradient at a particular point. You have to negate the gradient, and then you have to move in that direction proportional to the direction of negative of dy by dx. So in case of a three-dimensional space, rather than having differentiation, we use partial differentiation. So if I am writing dou of f by dou x, it means that I am differentiating f with respect to x, which means the slope of f in the direction of x. Similarly, if I'm taking the case of an n-dimensional space, dou f by dou some x1 will be the slope of that particular function along the axis x1. Next slide, please. Let's visualize this in a three-dimensional space. So I'll start from one point, and the gradient will decrease, and the negative of gradient will show me the direction, and finally it will reach the minimum. Okay, next slide, please. Okay, now I am plotting the cost function along one of the axes and the weights and biases on the remaining axis of this n-dimensional space. To find the least value of the cost function, we have to find the minimum of this curve plotted in the n-dimensional plane. In an n-dimensional plane, we use partial differentiation instead of normal differentiation, as I have talked to you earlier. So what we need to find is a gradient of cost function with respect to weights and the gradient of cost function with respect to biases as shown in this particular image. Next page, please. Yeah, next page. Okay, so once we have the values of the change of the cost function with respect to weights and the change of cost function with respect to biases, we now know in which direction we have to move in order to reach the minima. Now what we need to do is find new values of weights. Like in linear regression, Dhruv has explained that initially, we take values of these weights and biases as some random value, and finally we will optimize it to have the actual value. This is how it actually works. So we will start at some random point in the curve, and then we will move in the direction of negative of the gradient, and then we will finally reach the minimum. So the values of weights and biases are updated based on the gradient of the cost function with respect to the corresponding weights and biases. The rate at which we are updating this value is denoted by a hyperparameter called as the learning rate. Here you can see that if I'm taking the case of weights, then the new weight will be the previous weight minus the direction which you have to move. So I'm taking a direction proportional to that times a constant. This constant is like alpha. It's a parameter that we give to the model. We can change it depending upon the model. So we can have alpha basically tells us how fast we have to reach the minima. So if alpha is low, we will have it will take time to reach the minima. But if alpha is high, we can reach the minima faster. But the problem is that if alpha is very high, then there is a chance that we may overshoot the minima. So that is also a problem. So we have to choose alpha in such a way. Next slide, please. Okay, here the following figure shows the decision boundary of the model. So once you have trained the model, in this case, I am training the model with two initial inputs, x1 and x2. So like, let's take the example of like you are writing a test. I know, or I have some data with me, and in the data I collected, I have two parameters, x1 and x2. Let's say x1 represent the number of hours I have studied, and x2 represent the difficulty of the paper that the teacher puts, and I'm creating a model. I have also details about whether I pass or whether I fail. I am creating a model, training a model. Finally, the model create a decision boundary, something like this. So what we can do with this is that if I know new value of x1 and x2, let's say if x1 is higher, I am studying for more number of hours, and x2 is lower, I am like the difficulty is lower, like something similar to that. I can predict whether I will pass or fail. So as Dhruv has explained, disclaimer, this is not like don't do this at home. So it's not yeah. Okay, next slide, please. Yeah, here we have described like differentiated between binary classification and multi-class classification. So it's nothing that binary classification, as the name suggests, is a process or task of classifying in which a given data is being classified into two classes. So let's suppose two emails are sent to you. One is sent by an insurance company that keeps sending their ads, and the other is sent by a bank regarding your credit card bill. So the email service provider can classify these two emails. First one will be sent to the spam folder, and the second one will be kept in the primary one. So this process of separating them is called as binary classification. And in this, there are two discrete classes. One is spam and the other is primary. Multi-class classification, as its name suggests, is nothing but classifying element into different classes. Unlike binary classification, it doesn't restrict itself to any number of classes. So to take some examples for multi-class classification, let's say I'm classifying books according to subjects, or I'm classifying students according to their streams, etc. Okay, in these there are different classes for response. In these there are different classes for response variable to be classified in, and just according to the name, it's called multi-class classification. So my part has come to an end here. Feel free to ask any doubts or put it in the chat box. Thank you.
Anyone has a question regarding logistic regression? Okay. All right. Abhay Gupta, yeah. Go
Excuse
on.
me, sir.
Yeah. Can you go back, Suvit, to the previous slide? Yeah. Yeah, Abhay, can you ask a question?
Sir, how does the system decide from which path is it is going to reach the minimum?
Yeah. Sir,
Arjun, you
can you
wanna
take this?
answer that?
Yeah, I will do that. Can you go back? Yeah, that slide is good. That's like the animation slide. Yeah. So I'll tell you this with an example. So in first I took n inputs. I gave n inputs to a system. So let's say I'm giving two inputs to our model, x1 and x2. I'm creating a function y such that y equal to omega 1 x1, or let's say a1 x1 plus a2 x2 plus c. It's a general function, right? It's a curve in three-dimensional space. Okay. Now and like in this curve, the white line that you see here is a path it takes to one of the minima. So the white line starts from a particular point. So that's a random point, the random XYZ value that I gave initially to my weights and biases. So from there, I know the plot. I know this plot. So I know the curve. I know the derivative of this curve in all the directions. So I'll find the derivative of this curve in all the directions. I will like negate the derivative in all the directions, like I've explained in two-dimensional plane. Then like vectors, we will add them together vectorially to find the like the steepest point with which I have to move. So you can also visualize in another way. Let's say this is a hill. The image shown here is a hill, and you release the ball at one particular point. You know that the ball will always take the steepest path to move down. How does it do so? It does so in the same way. Like, yeah, it finds the steepest point, and the steepest point is found by like finding gradients, negating them, and then moving in that direction. So we will find this, and we will update the values of weights and biases by using that. So are you clear with that?
Okay, sir.
Uh, Arjun, there's a actually good question in the chat. You wanna take that too? Like,
Sir, you can take that.
okay. Uh, Venkataraya, that's a nice, like really nice question. Okay, if the ball stops in local minima or global minima, there are actually a lot of parameters and like there are actually a lot of hyperparameters. Sorry for using parameters, hyperparameters that go into optimizing your optimizer itself. So basically if your optimizer gets stuck in a local minima, it's stuck there forever, which you really don't want to. The objective of our deep learning model is basically not deep learning, sorry, of our model is to reach to the global minimum. That's our objective, right? But it's very possible that it can stop at local minima, and there are actually a lot of ways which is beyond the scope of this session. But there are actually many ways you can avoid the optimizer being stuck at a local minima. We'll have sessions on that later on. So if that answers your question, Venkataraya, does that answer your question? You can just write an yes or okay. Yeah. We can go on with the session, I guess. Is there any more questions? No, I don't see. Yeah. I guess is Harshit present in this meet? Harshit? Yeah, Harshit. Yeah.
It's audible, sir?
Yeah, it's audible. Go.
Good evening, everyone. I'm Harshit Sharma, and I will guide you through neural network part. So, ever wondered how do online services provide such accurate suggestion, ranging from your Google and Insta feed to shopping recommendations? Well, most of them are functional because of neural networks. So, let's dive into the most promising concept of deep learning, that's neural networks. Series of algorithms that identifies underlying relationships in a set of data through a process that is analogous to the way that human brain operates. A neural network is a network or circuit of biological neurons in a modern sense. An artificial neural network is composed of artificial neurons or nodes which attempts to mimic the neural connections in our nervous system. A neural network are composed of many layers, each layers performing a specific function, and more complex the network is, the more the layer are. That's why a neural network is also called multi-layer perceptron. There are a number of uses and important requirements of these neural networks. They are used in variety of applications, including financial services, from forecasting and market research to fraud detection and risk assessment, and can perform tasks like translation of text, identification of faces, speech recognition, controlling robots, and a lot more. The basic units of neural networks are nodes or neurons. A neural network contains layers of interconnected nodes, and each node is similar to multiple linear regression. For example, when used in image processing, these nodes or weights are some numbers that when multiplied to each pixel value of the input, give a new pixel value. Thus, propagate to the output where all new such pixels make the output image. A human brain uses its different sections to identify and process different kinds of data. In a similar way, a neural network does not identify the data at once, but rather uses its different layers to understand different parts of the input. We may say that for understanding a human face, the network first starts identifying various lines, then underlying parts of the face like eyes, nose, etc., and then is able to identify the face as whole. Now, we know that neural networks are computational graphs in which each step computes a deeper segregation of input data. But there are some reasons why neural networks are so efficient and powerful. They are good at existing patterns in data and extrapolating them. You can see a neuron as a mixture of signals of the neurons that signals to it, and it has thousands of similar neurons that mix the input signal differently. All these neurons in this way understand the complex pattern in steps, and with every step, these combinations become more complex and can cover more complex situations. Those situations are then identified as produced as output, thus producing very intelligent reaction to input signals. Neural networks in this way are known to find extremely complex pattern in vast amount of data. So they have ability to learn by themselves and produce the output that is not limited to the input provided to them. After understanding the pattern of inputs and their corresponding output, they can provide output to any following similar pattern. Thus, these networks can learn from example and apply them when a similar event arises, making them able to work through real-time events. A neural network is made of vertically stacked components called layer. Each dotted line in the image represents a layer. As you can see, there are three types of layers. First, input layer. This layer will accept the data and pass it to the rest of the network. Second, hidden layers. These are vertically stacked group of layers responsible for the excellent performance and understanding of complexities in input. They perform multiple functions such as data transformation, automatic feature creation, etc., and all at the same time. Uh, Third, output layer. It holds the result of or the output of the network. Each node is connected with each node of the next layer, and each connection has a particular weight. For each node in the hidden layer, a weighted sum is then calculated whenever input is provided. The sum is then passed to an activated activation function which performs specific transformation or calculation on the given sum. The sum is then passed on to next layer to perform further transformation. Basically, activation function is like an on and off switch. That is, it transforms the summed weighted input from the node into an output value to be fed into the next hidden layer or as output. In neural networks, the main purpose of the activation function is to introduce non-linearity into the output of a neuron. Next slide. Activation function is basically divided into two types. First, linear, and the second, non-linear function. This slide shows the linear activation function. Here, the function is plotted as a line, of which slope and intercept could be changed. As you can see, the output of the function will not be confined between any specific range. That is, this could even lead to age of -20 possible. To counterfeit this problem, we use non-linear function, which helps in solving even further complex problems. Here are some of the examples of non-linear function. Step function, sigmoid function, tan inverse, ReLU, leaky ReLU, and ELU. Out of these non-linear functions, sigmoid and rectified linear unit, that is ReLU, have been the most commonly used function. You have already learned about sigmoid function in logistic regression. It exists between 0 to 1, which is the range where probability exists for any event. This function is also differentiable and monotonic, thus becomes the good choice. Now, cost function. The cost function is the technique of evaluating the performance of a model. It takes both predicted output of the model and actual outputs and calculate how much wrong the model was in its prediction. It outputs a higher number if a prediction differs a lot from the actual values. A cost function is a single value, not a vector, but it rates how good the neural network did as a whole. There are many cost functions that are used in neural nets, like cross entropy cost, exponential cost, and mean squared error, out of which mean squared error is the most commonly way to calculate cost or the error. It is the average of the sum of the squared differences between the prediction and true value. Cost function is then fed to gradient descent algorithm to minimize the error and thus optimize model. Now, back propagation. Backpropagation, short for backward propagation of error, is an algorithm for supervised learning of artificial neural networks using gradient descent. This method calculates the gradient of the error function with respect to neural network weights. The backward part of the name stems from the fact that calculation of the gradient proceeds backward through the network. That is, the gradient of the final layer of weights being calculated first and the gradient of the first layer of weight being calculated last. Partial computation of the gradient from one layer are reused in the computation of gradient of the previous layer. This backward flow of the error information allows for the efficient computation of the gradient at each layer versus the naive approach calculating the gradient of each layer separately. Now that we have understood the basic concept of neural network, let's see an example of most commonly used neural network. That's CNN. A convolutional neural network is a deep learning algorithm that can take in an input image, assign weights and biases, and be able to differentiate one from the other. CNN is very efficient to find patterns within the image and produce output. The pre-processing required in a CNN is much lower as compared to other classification algorithms. CNN has the ability to learn important features of the input and output product accordingly. The architecture of CNN is analogous to the connectivity pattern of neurons in the human brain and was inspired by the organization of visual cortex in the eye. The architecture performs a better fitting in the image dataset due to the reduction in the number of parameters involved and reusability of weights. In other words, the network can be trained to understand the complexity and sophistication of the image better. Being a highly efficient and sophisticated neural network, CNN is applied to various fields of signal and image processing, such as facial recognition, cancer detection, and even biometric authentication. One of the most accurate implementation of CNN was AlexNet. It was deep learning neural network with 8 layers. AlexNet is considered as one of the most influential network in computer vision and has inspired many more networks deploying CNN to accelerate deep learning. It was a highly efficient neural system released in 2012. Over the year, many CNN networks have made an appearance and continue to evolve in the field of computer vision and deep learning. Here, my part come to an end. Now feel free to have doubts in the chat. Any doubts?
Anyone has a question? You can raise your hand or ask them in the chat. Okay. I would assume that no one has a doubt. So yeah, we can go on.
Good evening, everyone. Am I audible?
Yes, Aniket, you are audible.
Good evening, everyone. I am Aniket Roy, and today I am going to cover the part of computer vision. First of all, what is computer vision? What do you think that what it may be after hearing the name? Any guesses? You can write it in chat box.
Yeah, feel free to give an intuitive answer if you can.
Any guess you can write. Yes.
Analyzing the type of data.
Yes, very much correct answer you are writing. So, okay, computer vision is that branch of computer science in which we try to replicate the functionality of the human eye and make computers derive meaningful information from images, the same way as we humans do. Here we are basically deal with images. You can also refer it as eye of the artificial intelligence network. Next slide. Generally, we mostly deal with two kinds of images. One is grayscale images and the other is colored images. Grayscale images are made up of only one color and its different shades or intensities. That's why we call it single channel. As you can see, the only color in it is white and its different shades with gray and black being the low and lowest intensity of white respectively. Here please refer that gray and black are not different colors. They are also white color but with low intensity with black which is the lowest intensity. In color images, we deal with three types of colors which are mixed in different proportions to make any type of color. These three primary colors are red, green, and blue. In color images, we mix these three colors in different proportions or different intensities to make other colors. That's why in color images, we call them as multi-channel. Next slide. Now the grayscale images. Our computer does not know about any color. It just knows numbers. So how it perceives, stores, and reproduces images? An image is made up of many teeny parts which are arranged in a structured way. If you zoom in an area of an image which has different distributions of colors or shades, you will finally reach up to a point where you will notice that the area is divided into many small square blocks, with each square block having its own intensity which is uniform all over the square block. These small square blocks, which have their own independent color and intensity, is called a pixel. The combination of these large numbers of pixels with different intensities and occurring patterns in that area creates that part of the image. So, to remember an image, our computer just remembers the intensity values of all the pixels. But wait, computers don't understand color, neither it understands the intensity. So it remembers their intensity by a nomenclature, where highest intensity is assigned a value of 255 and lowest 0, and intermediate intensity in between 0 to 255. So our computer sees the image as nothing more than a number matrix with entries of 0 to 255. Only white color and its different shades or intensities are used in grayscale images. That's why we call it a single channel. Next slide. Here's a very nice example. As you can see how this image is made up of many pixels, each having its own independent intensity. And the collection of these pixels and distribution and their occurring pattern makes up the image. Also, you can see how the computer is seeing the image. It is not seeing the intensity or color. It is just seeing the pixel value corresponding to their intensities at their corresponding places. It's a small image of only 22 into 16 pixels. Just imagine in high resolution pictures of 720 into 1080 how much details and fineness can be shown. Next slide. In color images, we stack together 3 different channels of red, green and blue, one over the other, to make the color image. Different shades of red, green and blue can make any color. Here also, computer sees the image as a number matrix, but here it sees it as 3 independent number matrices representing each color of red, green and blue for one image. Here it is a 3-channel image. Please remember that each channel is similar to the grayscale image where the channel is white. In this, the channels are of different colors and these 3 channels are superimposed over one another. Otherwise, the properties with the grayscale image are just the same. Please remember this. Next slide. Here you can see how these 3 different channels are superimposed over one another to create the color image. Each channel is the same as we saw in grayscale. The only difference is in the color. Next slide. Now since we know that an image is made up of many pixels, we need to define their position to get easy access to them. Here we use the coordinate system, our own convention, to get the position of a particular pixel. In this convention, the origin is assumed to be the upper left corner with positive x-axis towards right and positive y-axis towards down. Now we have learned about images and how they are represented in computers. Let's show some pixel operations. In pixel operations, we manipulate the different pixel numbers, which are 0 to 255. And since pixel numbers define their intensity, and combination of these pixels make the image, so we manipulate the image too. We can change the brightness by adding or subtracting a constant from all the elements of the number matrix. Also, if you multiply or divide the elements by a number, we can alter their contrast. In the number matrix, the pixel values are there. And if you change the pixel values, the image will also get changed. If we add some number or subtract some number, the pixel values will more or less close to 0 to 255. That's why their brightness gets changed. In contrast, contrast is nothing but just the difference between the pixel with highest intensity and pixel with lowest intensity. So multiplying them with a number certainly change the contrast. In this example, you can see that here are 2 images, and in both the images, there are some constant multiplied and some constant added to change their brightness and contrast. Next slide. Now we will discuss about one of the most important image processing operations, convolution. So what is a convolution? In convolutional operations, the value of a pixel is assigned by adding the weighted pixel values of its neighboring pixels. In this way, we extract a new image out of the input image, where each pixel value of the output image is the sum of the neighbor pixel values of the original image weighted by a kernel. Here, these white boxes, as you can see, these are the output image, and the blue boxes are the input image. And the shaded region is the kernel, which is taking the weighted value, weighted sum of that pixel and generating the output pixel on its place. Kernel is a 3 into 3 matrix, which is we are using here, which is traversing over the whole area from left to right and from up to down to convert the whole image. Next slide. In this picture, you can see what this kernel is. It's a teeny matrix with its own elements, which are element-wise multiplied with the corresponding small part of the image which it overlaps. And then a sum is computed. Note that a kernel should have an odd size, as there should be a center place present in the kernel where the output value is assigned. In the previous example, we have seen that shaded region was traversing over the whole image, and it was taking the weighted sum of the value, and the sum is generated and it is stored in another image pixel. In this way, this kernel is traversed over whole the image, and at each step it stops. The area which it overlaps, it takes the element-wise multiplication with that pixel values find out the sum and put it in the output image at the place of the central pixel. Here it is an example of an input image which is at the top and the different convolution operations which are applied on it by different kernels. With this matrix kernel, we get this image which is a bit sharp. With the middle kernel, we get the middle image which is blur, and in the right one, we use this kernel to get this type of image. Next slide. Now, edge detection. First of all, how do we humans detect edges? Basically, we detect edges when there is a sudden change in color or intensity. Whenever we see there is a change in color or intensity, we detect it as an edge. Here also we exploit the same fact. We design our kernels in such a way that whenever there is a change in the intensity of pixel values between two regions, it will generate a boundary between those two regions after convolution. Here in this small example, if you do the same steps as discussed earlier, like taking the kernel and doing convolution over the whole image starting from the upper left corner, if you do these steps, you will get the output image as here it is indicated. Here you can see that a boundary between these two regions have been created. So our computer have successfully detected the edge between these two regions. The left region is of higher intensity, the right region is of lower intensity, and after doing the convolution, it is generating a boundary between those two images. Here are some of the kernels given. These kernels are used to find the vertical edges of an image. And the kernel for getting the horizontal edges of an image, you can just take the transpose of these kernels and traverse these kernels over the image. You will get the horizontal images or horizontal edges. Now, if you superimpose the vertical edges with the horizontal edges, you will get the overall edge of the image. In this way, we extract edges of an image. So these are from my side. Now the session is open for doubts. If you have any doubt, you can ask.
Yeah, Thakur Satvik, go on.
Sir, I had a doubt in the part of that kernel where you told about the blurred image, the over underexposed, and the normal image. How are we classifying the different types of kernels that? How are we putting those numbers in those boxes?
Uh,
It is not identified by us. Many scientists have a work on that, and they have generated these kernels for these operations. Like there are also Gaussian kernels, there are Laplacian kernels. They have already experimented on that, and they have told that we will use these kernels to get this type of output. Here also intuitively you can get that the blurring kernel, as you can see, it is just taking the average of all these neighbor pixels. That's why the image get blurred. It is just taking the average. See?
Okay, sir. Thank you, sir.
yeah. Is there any more doubt? Thakur, can you put your hand down if you're, yeah. Is there any more questions? Okay. Sure. Okay. Since Priyam, it's available on YouTube. It's being it's live right now as of we are speaking. So you can go into hop into YouTube and see it whenever you feel like to. Since we don't have any more questions, I think we can end this.
Sir,
Yeah.
excuse me, sir.
So we're going to demonstrate the Discord,
All right.
joining the Discord server.
Sure, sir. Go on. Go on. Good with that.
Yeah. Karan, you'll present him. Yeah, just a minute.
Is my screen visible?
Yeah, it's visible.
Great. So you will be given a link for Discord server. So you either have to just click on it or join the server will open. I am here pasting the link for a spare account. So whenever you will paste the link, it will say Discord app launch, continue Discord. So better continue to Discord, or if you are having a Discord app on the PC, it will open directly. As it is my spare account, I'm doing it on browser only. Or also you can go from here, join a server, invite link, copy, paste the invite link and press join server. It will take time. So whenever you join the server first time, it will show your enter password here. Yeah. So you can here enter the password. The passwords will be provided to you for the each and every group. We have created different password so that there is nothing mess is not created. So suppose I enter a password the first year. Okay. I enter that password. Oh, just a second. I entered the wrong one. So don't do that. This is one-time password. If you enter the wrong, it would not get. You will not get the role and you will not get the access. The here I have entered the first year. So this access is only for the first year. See, this is the server. For the first year, this is only access. If you enter the password for the group, you will see your group here, group 1, group 2. We are not disclosing that passwords presently because of some reasons. So you will be given the password, you just enter to the channel, you just do that, you just paste the password and everything will be accessible to you regarding to your role. So let me show you how to use Discord. So this was just the demonstration of how to get into Discord or how to start using, how to get into server. So for that, let me give myself a role first. Okay. Now assign myself the role of mentor for temporarily. So here you can see group 1, group 2, group 3. So all the groups are divided. If you are in the group 1, you will only be able to see the group 1 things, the text channels and the voice channels of group 1 only. For sending the message in a group 1 text channel, you just have to press on it and you can write anything here, right? So you can write anything. Mentors will always be available here for you and you can definitely ask your doubts here. So this is the voice channel. For joining it, you just have to press on it. Okay. You will be pressing and you will join the channel. So this is a very great way to manage everything, and also the voice channels quality is also very great. So this will be the Discord server which you will be using. If you want to ask anything regarding the doubts regarding your problem statement doubts, you can ask here. Yeah. So if anyone is having doubt regarding this Discord, can definitely ask me.
Mentors can also will be also taking the meets on Discord server. So like you can join there and you can see that who all are there. So it will be an easy way to contact with each other.
Yeah, you will
Link
get
will
the
be
link.
provided in
Yeah.
group.
You will get the link along with the passwords. Yeah, it definitely will be fine. Definitely will be fine in using the mobile. But I will suggest keep it open in background in PC rather than mobile. PC has a very good user interface. In mobile, you can miss the channels. You have to navigate between the channels. It can be difficult for some time, but most of the time it is great.
Yeah, there will be all the groups in the WhatsApp group will be separate here. It's like you will be only able to join one group like group 1 or group 2 like that.
So the voice channel is also like a Google Meet only. Here is that everything is in on one Discord server only. We don't have to give you the separate links for everything. You can just join the voice channel for any meet.
You are already in the BotAstra groups in WhatsApp. Like if you are in group 4 in WhatsApp, so you'll be joining here group 4 only. Yeah, BotAstra group WhatsApp groups.
Is anyone else having any more doubts about the session today or about the Discord thing? All right. So since no one has any more doubts, I think okay.